So yeah, so we're gonna talk about making better command line applications, not just command line applications. And so the real idea here is to make applications that other people won't hate to use or maintain. Before anyone asks, the slides, some notes, and the example code are online. I'll have this URL up again at the end of the talk, so you don't have to worry about copying it down now. So first I want to talk a little bit about philosophy. This is the Zen of Python. If you haven't seen it before, Google it, or in a Python interpreter, type import this. It's basically a set of principles that influence the development of the Python language, but you can use it to apply to your own development as well. And then along the same lines, there's the Unix philosophy. And so this captures the approach of Unix software development. There's been many versions of this kind of restated over the years. I picked this one mainly because it fits on a single slide, but also because it kind of captures the essence of command line applications. And now for just a minute, I want to focus in on that middle one. So write programs that work well together. So I'm going to give a little background information because I know people have different levels of experience, especially with like Unix and Linux and command lines. So there's the POSIX standard or set of standards, which describe how operating systems and programs should work together. And we're going to look at a couple of the major points of it. This is by no means all of it, but it'll help with the rest of the talk. So programs have access to these virtual files called standard streams. There's one for input and two for output. So you have the input ones called standard in, the output ones are standard out and standard error. So the idea is your program writes its results to standard out, and it writes any errors or diagnostic information to standard error. And if you need to provide data to the program, it can be read from standard in. So now typically, standard out and standard error will both go directly to the terminal, and that'll be displayed in front of you when you're using the program. But you can change where those streams go via redirection. So here is an example of using the grep command to find text, and we're trying to find the text hello in any of the files in the directory that we're currently in. And we see that there is a result. It found hello world in example.txt. But there's also two lines of diagnostic information. One saying that it can't find text in a directory, and the other one saying it can't read this protected file. So if we're just interested in the results, having this diagnostic information mixed in with the results can be kind of annoying. So there's this idea of redirection where you can send the results to one place and the error somewhere else. So here's an example of using that same command, except we're redirecting the standard output to a file called matches.txt. We still see the diagnostic information from standard error printed out, but we would see that matches.txt contains just the output of the grep command. And then we can redirect both of them if we want to different places. So here we're redirecting the standard out to matches and the standard error to this diagnostics.txt. And we'd see that diagnostics has that information. I don't want to get too much into how this all works. You can look up the syntax yourself if you haven't seen this before. But I wanted you to be aware of this because it'll help in a little bit. And then the other thing that's important to know about is pipelines. So this allows you to connect the output of one program with another program, and then you can string multiple programs together and they can combine forces and do better things for you. So in this case, or with a normal pipeline usage, the standard out of the program to the left of the pipe goes to the standard in of the next program, where the standard error just continues to go to the terminal like it would before, unless you also redirect that. But we're not gonna do that. So pipelines allow you to connect multiple programs together. So why do we want to write command line applications at all? So for me, they're really good at automating tasks that are repetitive. And they're especially good when you know what all the inputs are going to be up front. So you don't need that interaction. So these things can be run on a schedule behind the scenes. You don't have to be aware of when they're running. And then they can be integrated with other system tools via the pipelines that I showed. And why would you want to do this with Python, though? Because you can definitely use shell scripting in a bunch of different languages. So Python has a very rich standard library that can do a lot of things for you. And then the Python package index is full of pretty much every type of program that you can imagine. So if you want to do something with a computer, Python can probably do it for you. So take advantage of that. The other reason I like Python is because readability counts. And if you're doing this in any sort of work setting or even your own tools and you go to look at it a year later or 2 years later or someone else has to maintain it, I find looking at someone else's Python code from 2 years ago is a heck of a lot easier to understand than someone else's shell scripts. And then Python has some really great argument parsers. If you've ever looked at a shell script that's doing argument parsing, it can be kind of confusing and not everybody does it the same way. With Python, it's pretty clear what's happening with the argument parsing. But there's definitely places where I wouldn't use Python. So if I'm just executing a list of commands, that's a shell script. If I don't need to support things like options or like optional arguments and or complex logic based on that input, I'd probably use a shell script. You need to draw the line for yourself, kind of where you feel comfortable. For me, that line's usually now where there's optional arguments. I use Python. So we're talking about a good Python command line application, though. And so in my mind, this is an application that's informed by the Zen of Python and the Unix philosophy. So we're going to try to keep those in mind as we go forward. So now we're going to get into some of the specific ways that you can make command line applications that fit in. The first thing is having positional arguments for required input, and then options using the standard 2 dashes for the long version of the option, and a single dash, single letter only for the most common options that would be available. You should have a dash dash help so that people know how to use your program if they haven't seen it before. And then you should support common things like verbose. If you're going to output additional information, use verbose because people expect the dash dash verbose. They don't expect like dash super extra logging info or something like that. So use the standard things. And the really important thing was we want to support that standard in, standard out, and standard error so that we can use our program with other programs. It just pains me when I have to use a program and I can't pipe output from something else into it. That's really annoying. And there's really no good reason for that to happen anymore because there's tools that help you do this pretty easily. Your program should exit with a meaningful status code, so they should exit with 0 if everything was normal or it was successful, and non-zero for a failure. This allows your program to be used in conditionals in shell scripts, so people can combine your program with other things. And then if you have a long-running program, you should support signals, which tell the program to do things like reload a config file or to shut down gracefully. But at minimum, you should support handling a keyboard interrupt. So when you're running a program and you do Control-C, it's going to raise a keyboard interrupt. You should handle that gracefully. So if you're writing files, you should close the files and things like that. And then your program's configuration should be stored in an appropriate place for that platform. Now, again, there's tools that will tell you the right location. So if you're on a Linux system, your user configuration is going to be in one place, in like a dot file in the home directory. If you're in Windows, there's another place that's typical for that platform. So use the tools that give you that information so that you're doing what other people expect. And then configuration should be overridable, and I'll talk about how you should implement that. So with configuration, you want to have this kind of cascade of less specific to more specific. So you should start with a sane default if you can for any of your options. So if you just run the program and you haven't configured anything, it just does something that you'd expect. But then if you want to have configurable values, you can store that in a config file. So you'd read the config file, and if that exists, you'd use that. But a lot of programs support storing configuration in an environment variable. So if it's in the environment, you should use that instead of the config or instead of a default. And then the most specific is if an option's passed on the command line, you should use that instead of one of the others. I can't remember, I was trying to think of the example of something that if there was a value in the configuration file, it used that instead of what you passed on the command line. And that is most definitely not what I expected. So that caused me problems. So don't do that. And the next thing is colors. And they can make output clearer, but they should only be used if you're going to use them correctly. And the most important thing is that colors are disabled when the output isn't going to the terminal. Because if you don't do that, what will happen is you'll see a bunch of control characters mixed in with your output text. And that makes it hard to pipe the output to other programs. Again, luckily, there are tools that handle this for you, so don't try to detect it yourself. Use those tools. So I want to go over the Python command line parsers that are available. There's a few in the standard library, and you can get as low level as just reading the arguments that are passed in directly and parsing them yourself. I don't recommend that. I'll let someone else do the work. Getopt and optparse are kind of the older. Getopt is for compatibility reasons, and optparse is an older parser. So really, if you're stuck with the standard library, you should be using argparse. But there's a ton of great command line parsers available on the Python package index, and this is just a few of the popular ones. I'm going to cover two of them just so you're aware of them, but I definitely recommend using clique or docopt if you have the opportunity. If you're really stuck with the standard library, go with argparse. So before I get into the differences between those, though, there's a little bit of code that's common to any of these. So the first part is Shebang Line, which is the first line of your program file. On some examples online, you'll see people say, like, use user bin Python. The problem with that is if the program is executed directly from the command line, it might be using the wrong version of Python that's installed. So a lot of Python programs are meant to be run in a virtual environment. And so if you use user bin env Python, it'll pick the right Python interpreter and run that. So if your program's Python 3 only, you can do user bin env Python 3. Otherwise, user bin env Python is what you want to do. What's really neat is this is even supported on Windows now. So with the latest versions of Python, or recent versions of Python, on Windows, it'll do the right thing. It'll use the virtual environments interpreter. Your modules should be able to be either executed directly or imported. And the way you can do that is by adding this little bit of code. And what this does is it checks the special variable name and sees if it's the special value main, which means it was the program that was directly executed. If it is, it's going to run the CLI function. But if it's not, so if someone else imported this, it's not going to run that function. And this allows someone else to import your code without running the command line interface, which is probably not what they expect. Now, I recommend laying out your package so that the module or modules that do the interesting thing are separate from your command line interface. So what this does is it basically makes your command line interface a controller for your module that actually does something interesting. And I found it causes you to create a better API in your module. It also allows you to refactor that command line parser later if you want to. So if you're using argparse now and you want to switch to clique or switch to docopt, it makes it really easy to do that. And then when you're packaging your program, part of the packaging is configuring a file called setup.py. And one of the configurations in setup.py is called entry points. And this defines interfaces to your package that other packages can use. There's a special value of entry points called console scripts. And what this does is it maps command names to package, module, and function name. There's a different way of adding executables to your package, but don't use it. You should be using the entry points. And the reason for this is platform independent. So if you install this on Linux or Unix or Mac, it's going to create a little shell wrapper, like that first example is hello world. It's going to be placed in your path, and it's going to map to the right Python interpreter in that function. On Windows, it's going to create a small executable called hello world. And so this is completely platform independent. Otherwise, if you use the shell scripts instead of entry points, it's only going to work on Unix-like systems. So we're going to take a look at argparse. Like I said, this is the one that's in the standard library in any of the supported versions of Python. So if you're stuck with not being able to install any extra dependencies, you'd be using argparse. So we're going to look at a hello world real quick. So we import argparse, and we're going to define a function that's going to run the command parsing. We create a new argument parser object, and we add a required argument called name and an optional argument called count that has a default value. We call parsers parse args, which stores the parsed input in an args object. And then we can reference those values from that args object. So in this case, the hello world is just going to print hello, whatever name we passed it, whatever number of count times. So we see if we now run the program with --help, it generates help output for us. So when we get all the usage information we'd expect to see from a command line tool. So now if we actually run the command and we don't give it that required argument, it's going to pass back that we didn't pass enough arguments, so it gives us that error information. If we run it with the argument, it gives us the output we expected with that default count of 1. And then if we specify the count, it uses that count, so it prints it 3 times. So now we're going to take a quick look at clique. Like I said, this is available via the package index. This is what I use for all of my command line interfaces now. And I do that because it helps me kind of do the right thing by default. So it makes it really easy to make a program that acts like a good program should. But first, I just want to mention decorators in case you're not familiar with the syntax. It's a special syntax using the @ sign that allows you to take a function and then wrap another function or object with that to give it new properties or new behavior. Clique uses them a lot, so I just wanted to call that out in case you weren't used to seeing it. So we're going to do that same hello world program, this time in clique. So we import clique, and then we use a decorator clique.command. And so this says that the function that we're about to define is a clique command. We add a clique.argument, which is called name, so that's the required argument. And then we add an option called count with a default of 1, just like with the argparse example. We define a function, and this time those, the argument and option are passed to the function as function arguments. And then we can reference those variables inside inside our code. So it's going to do the same thing where it prints hello world or hello name count number of times. So we see we run the program with --help, and it gives us very similar help output. So it generated that automatically again based on how we configured it. And then if we run it on the command line, it does pretty much the same thing, where if we don't pass that required argument, it tells us it's missing. If we run it with the argument, it uses the default count. And if we specify a count, it uses that. Sure, yeah. What's the question?
So, I'm just curious, why clique versus argparse? I'm sure you have some reasons.
The question was why clique versus argparse, and I'll talk about that a little bit more in a bit. So, and then if you still have questions, we'll go there. So I wanted to take a quick look at docopt because it takes a very different approach, and I've seen people mentioning it and using it, and I've seen examples of kind of popular programs that use it, so I didn't want to leave it out. So instead of generating help text from your parser configuration, it works the opposite way. You specify the help text, and it configures the parser based on that. So we're going to look at a hello world example that does the same thing. So this time we specify that help text as the doc string for the module. And so the syntax for this is specified on the docopt docs, so you can see that. But it uses a really standard layout. So then we import docopt. And then in our function, we use docopt to parse the inputs to the program based on that doc string. And then in our function, we can reference the passed arguments that are stored in that dictionary args. Note that the dictionary keys include the dashes or the brackets that are around the variables. And so the help text is what we'd expect because we just typed it in, so there's no surprise there. Then we run the program. If you run it without that required argument, like the others, it outputs usage information. It doesn't give the error message, but it's still really similar. And then if we run it with the argument, it uses the default count that we provided, and if we specify a count, it does the thing count number of times. So let's go ahead and make that better command line application, though, that we were talking about that kind of takes things into account. So it's going to read from a file or from standard in. It's going to write to a file or to standard out. It's going to update a log or standard error. It's going to have an option. It's going to use colors, and it's actually going to do something. So the example program, it's still pretty simple. It's not terribly useful. It's going to count the occurrences of each character in some sample text, and I just used the Declaration of Independence since it was freely available to use as sample data. So we're going to create a new command line module. At the top, we do our imports. So we're going to use clique, and we're going to use some properties of sys, so we're going to import that. And then, like I said, I split the logic that actually does something out from the command line interface, so we could re-implement it later using a different command line interface if we wanted to. So I just created a simple thing called counter. So we're going to do the same decorators where we say this is going to be a click command. We're going to give it an argument, a typically required argument of infile. And clique has type validation, so it's going to make sure that the infile that we gave it is openable and readable. And we're going to pass this special default value of dash. And so what that does is if you don't pass a value for infile, it's going to use standard in by convention. And that's a POSIX convention that they're not just making it up. And then we're going to do the same thing with the output file. So out file, we're going to make sure that we can open it as writable. And we're going to use that default of dash. And so for output, or for anything that's writable, a default of dash means standard out. And then we're going to add an option for a log file. And so this file, again, needs to be something that's writable. But we're going to have this default to standard error. So it'll print a standard error if we don't specify a file. Then we're going to add an option for verbose if we want more debugging output. And then we're going to define the function. So and we'll see the function CLI gets passed all those values, the in file, out file, log file, and verbose. Okay, so this is the rest of the program. So if verbose, we're going to just output some extra debugging information. And clique has this function called echo, which is nice. It will use the right version of print for the version of Python you're on, so it's Python 2 and 3 compatible. But it'll also write to files if you want. So in this case, it's going to write to the log file if verbose is set. And then we're going to read from the input file, which by default is standard in. And we're going to use that counter to get the character counts and generate the output. The format of that here isn't important for our purpose. And then we're going to output some diagnostic information. So we're going to say we counted the characters. And then we're going to use clique's S echo, which is styled echo. So we can set the output color to green. So it's going to output with color if it's being output to a terminal. And then if verbose, we're just going to say that we're done. So just like the other examples, if we run -- help, it's going to give us the generated help output. And then if we run the program specifying an input file in that first position, it's going to read that file and count the characters and give us the output. And I neglected to make it green, although it probably wouldn't have been as readable here. So that's OK. In the real example code, it does output green here. So now instead of reading from a file that we specified, we're going to pass input to it via standard in. So we're just going to echo the string test, and then we're going to use a pipe, and then clique, which is the program, and it reads from standard in that was passed to it and does the same character counting. And now we can do the same thing where using that special dash, we're reading from standard in, but we're specifying an output file. We see standard out got written to results.txt, where the standard error that counted characters diagnostic line still printed to the terminal. So we're going to run the command again. This time we're going to use the verbose option. We're passing data into standard in. We're going to use the log file to save the diagnostics, and we're specifying an output file. So we're kind of using all the options now. And you'll notice it doesn't print any output to the terminal. That's because we redirected everything. So the out.txt contains the results that we'd expect. And in this case, and again, if you run the example code, you'll see that there's no color control characters mixed in there because it's going to a file instead of going to the terminal. And then if we look at that log.txt, we can see the diagnostics information that was printed from the verbose logging. Okay, so I just wanted to mention a couple extra things. So I just kind of gave you an overview of the basics. So hopefully you kind of know what to look for. So when you're packaging code for distribution, there's a lot of boilerplate or a lot of repetition, like your setup.py, manifest.in, a lot of those things. So I highly recommend using a project called Cookie Cutter, which will take a template repo and make a skeleton of a new project for you with those values filled in. And so I recommend finding a Cookie Cutter template that is close to what you want, modify it for your purposes, and then base your new programs on that. I have one that I use that I have on GitHub, but you might find there's a couple options that you want to change and kind of use that as your default. Logging, I kind of did it in a little bit of a hacky way there with writing directly to standard error or to a file based on the input. Python has a logging module that allows you to define a lot more options than just that. So I'd recommend you use that. And if you're using clique, there's a package called clique log that integrates clique's standard error output with the standard loggers. So in summary, I think if you keep the Zen of Python and the Unix philosophy in mind, you're going to end up making better command line applications. So thank you. And like I said, all the examples and links are going to be there. So I can take a couple questions if people have any. Yeah.
I think you mentioned exit codes early on, and then do you have any comments or guidance on exit codes?
Yeah, so the question was if I have any comments or guidance on exit codes. I mean, basically, the idea is if your program did everything you expected to the right way, exit with 0, so there's no error. And if there was an error, exit with 1, unless you're doing something like grep does, where grep will exit with 0 if there's a match or 1 if there's none. So if you're doing something like that where you're trying to the goal of your program is like matching or not, that's what you'd use that for. But so basically you want to keep in mind how someone might use your program in a conditional, because that's really what it is mostly used for. You can use more specific exit codes, but the conditionals pretty much just look at 0 or non-0. Yeah.
To follow up on that, actually, I find that a lot of people will write their own errors and come up with their own codes, but POSIX OSs in general, like the press standard sys, if you call out various functions, there'll be things like there's called errors, I think, is the module, and it contains the actual POSIX codes for the errors and verbal statements, like no access, for instance, or permission errors and things like that. And I would recommend using those and adding those in the program, like the.
Okay, so the comment was that there's errors module that will output the standard POSIX error codes for you. Yeah.
So if you know something like argparse well already,
Yeah.
why, just kind of out of curiosity, why would you consider switching to something else like clique or doc?
Right. So the question was if you're already familiar with argparse, why would you switch to clique? So like I was kind of mentioning in a couple spots, there are places where it does things that I think get you closer to that standard POSIX program. And some of the things it does for you is like it incorporates another module or another package called Colorama, which does that like colorized output, but it handles it automatically for you. So if you're printing to the terminal, it's going to be colored. If you're piping it somewhere else, it's not going to have the color control characters. So I mean, that's just one example. But basically I've found that clique seems to get out of my way more as I've started using it more. Yep.
Just to follow up on what he's saying, what I've noticed is that argparse, you define all the arguments on top when your code comes later,
Mm-hmm.
where with clique, you wrap it so your arguments kind of stay closer to the code.
Yeah. So the comment was that with argparse you define everything kind of above, or you can actually define it in a lot of places, and then with clique, everything is all in one place, wrapping the code. So, and I agree, and actually that's a good point. So with clique, it's very clear just from the stack of decorators what the entire command line interface is. And something else I didn't show was clique has really good support for nested commands. So if you've used git on the command line, git is the main command and then a subcommand. And clique has really good support for that subcommand idea. So it handles like options that are passed to any command or all commands, and then options that are specific to the subcommand, and generating the help for the subcommands versus the base command. It does all that very well. Okay. Oh, one more.
Are there any cases where you would favor using doc over?
So the question was if there was any case that I would favor doc opt over clique. Not for me. I wanted to show DocOpt because I know it is popular in some scenes. I mean, there's some people that use DocOpt for all of their command line things, and so I didn't want to leave it out. It's just a different way of thinking about it. I wouldn't say that they're equivalent. The thing that I found harder to do with DocOpt was when I was doing the subcommands. Getting it right was just harder. Although, because DocOpt, you start with the that help text, it's probably also just a matter of getting used to that syntax and memorizing how you generate the help text and getting the format right and things like that. But I never made it over that learning curve. So with clique, I found the decorator names and the options are intuitive enough that I don't have to reference the documentation that often. So, cool. Well,
Does clique have any support for getting input interactively?
the question was, does clique support getting input interactively? It does have really basic command prompt functionality. There's also a couple third-party or other modules that do that in a more advanced way. So yeah, clique has like a whole set of utilities, and if you just Google like Python clique utilities, and there's a list of things. It also does things like progress bars and I'm trying to think. Of course, I'm not thinking of them at the moment. But yeah, so there's a bunch of just kind of nice to have things that are built into it too. Cool. Well, thanks.